This is Algebra 2, Lesson 6.5, the remainder and factor theorems with dividing polynomials and relating results to the remainder theorem and factor theorem, beginning on page 352. Two definitions to start. First one is polynomial long division. I just want you to pay attention to what this says. We're not going to use polynomial long division. I'm going to show you why in just a minute. But polynomials know what that means. That just means more than one nomial, poly. More than one number or more than one term in it. And then you know what long division is. That's that thing that you quit doing as soon as you learned how to use a calculator. So I'm going to show you a way to where we can quit doing it before we even start polynomial long division. This is the way we're going to focus on. This is the easy one to understand. It's the quick way to do it. And once you understand this way, there's absolutely no reason to go back to polynomial long division. That being said, you don't even have to understand long division to understand how to use synthetic division. That's why we're going to jump right to it. It's a method used to divide a polynomial by an expression in the form x minus k. The drawback to synthetic division versus long division is synthetic division, you can only divide by a binomial, something that has two terms. Fortunately, that's all we're going to focus on in this class is things that are divided by two terms. Example number one, if you want to take a look at it, if you think you might have gotten it right, you could take a look at some of these numbers. Otherwise, I don't want you to focus on it at all. If you want to go back and watch the video later, you can do that. The remainder theorem is a polynomial. If a polynomial f of x is divided by x minus k. So it's just saying two terms. That's all you have to worry about. Don't think about x and k and stuff like that. Two terms. The remainder is r is equal to f of k. And I'll show you what that means right here. It says to divide x to the third, or x cubed plus x squared minus 5x plus 3. Notice that's four terms in that polynomial divided by x plus 2. So the remainder theorem says that if it's in the form x minus k, because x plus 2 equals x minus a negative 2, therefore k's value is negative 2. Okay, that's a whole mouthful of stuff to say, but when you look at this binomial here, this is what you need to focus on. Looking at that binomial x plus 2, use the opposite of whatever that is. That's the easier way to think of it, the opposite. So it says x plus 2, you're going to use negative 2. If it had said x minus 2, you use positive 2. In synthetic division, the only mistake that students ever make is they forget to include factors when it skips a degree. So if for some crazy reason it says x to the third plus x plus 1, if it skips x squared here, you can see this one says 3 and then 1, it skipped x squared. It skipped the second degree. That's the only time students ever make mistakes with this because it's such an easy concept to get. This is how you set up synthetic division. You draw yourself a box like this, and I'll take them one step at a time real quick. You draw yourself a box, and you leave off all of the variables and all of the degrees. Notice in the box, it just says 1, 1, negative 5, and 3. We're just leaving them off for now, and we're going to put them back in just a minute. Again, if for some reason it skips a degree, you have to put a placeholder in there. You have to put a 0 in place of the coefficient. This is the same negative 2 I told you about a second ago right here. That's the negative 2 that goes outside the box. So the first thing you do is you take that first 1, and all of these numbers, 1, 1, negative 5, and 3, all of these numbers, 1, 1, negative 5, and 3, come from the coefficients of this polynomial. That one's 1, this one's 1, this one's negative 5, and this one's 3. So that's where those numbers come from, 1, 1, negative 5, and 3. So the first thing you do is you take that first coefficient and you just bring it straight down. Notice nothing changes between the top and what's underneath that box. Then what you do is you multiply that number times this number here. You go back outside the box. 1 times negative 2. And notice in this spot right here, it says negative 2. Then you combine these two numbers, 1 and -2. When you combine them, notice what's underneath the box then. 1 combined with -2 is -1. Then you go back to this number. You keep going back to that number that's outside the box. It's a very easy thing, but it's new. -1 times -2, and you're going to get a +2. That's what we have right here, +2. Then you combine those numbers again in that stack. -5 combined with 2 gives you -3. Then you go back to that number there. We're going to keep going back to it every time. -3 times -2, we know a negative times a negative is a +6. And then the last thing you do is you combine those two numbers there, 3 and 6, to get 9. Now what we have is a bunch of coefficients. We got 1, we got -1, we got -3, and we got 9. What you do from there is you go 1 degree less than what you started with. We're just going to take these numbers, 1, -1, -3, and 9, and we're going to go 1 degree less than what we started with. What was the degree we started with? X to the what power? The largest degree. X to the third power. Look at it right here. X to the third power. We're going to go 1 number or 1 degree less. So 1, so just taking it right from each one of these coefficients, this first one, 1, it's going to say x squared because it's 1 degree less than x to the third. The next number is this one I have in black right here, -1. What's the next degree? If we have x squared first, what's the next smaller degree? X to the what power? You always count down with your exponents. So if it's x squared, what's the next one? X to the what power? We have squared here, so what's the next littlest one? It's not a trick. X to the first power. The next one right here, -3 minus 3. What's the next degree if you go down from x to the first power? It'd be x to the 0 power, which means there's no x. So now what we did is we have x squared, x to the first, no x. So x, so if we eliminate these numbered coefficients that don't mean anything, we have x squared minus x minus 3, but we have one more number. We have +9 right here. So +9 is called the remainder. It's positive, so you put all of these together. This is one polynomial, and it's +9. You put it back over the original thing you divided by right here, x plus 2. So x squared minus x minus 3 plus 9 over x plus 2. That's the remainder. We're going to look at another one that has less stuff in it that you'll be able to see and work on a little bit easier. On the back, let's not look at the second one real quick. On the back, let's divide x cubed minus x squared minus 2x plus 8 by x minus 1. Take about 30 seconds and see if you can get through some of that. First thing you want to do is draw yourself a box. Something like this. Maybe a little bit longer. Then you want to list your coefficients. Remember your coefficients. This one's 1. This coefficient is what? -1. Don't forget there's a negative. This coefficient, it's -2. And this one is 8. It says to divide it by x minus 1. What do we do with the x minus 1 if we look back at the example from a second ago? What do you do with negative 1? You change that sign. So we're dividing it by positive 1. So we're going to take all four of these numbers and we're going to use that and divide it by 1. So remember, the first number just comes straight down and put 1. Then you multiply that number. You go back to this one every time. 1 times 1, we combine it right there. If we combine the two that are stacked on top of each other now, negative 1 and 1, we get 0. Then we go back again. We're going to keep going back. 0 times 1. We get 0 right there. If we combine negative 2 and 0, we get negative 2. Then we're going to go back again. Negative 2 times 1, one more time, we're going to get negative 2. If we combine those, 8 and negative 2, we get 6. So now we have 4 coefficients that go with what we have. Now look back at your original polynomial that you divided from, the bigger one. X cubed is what it says. You want to start 1 degree less than that. So instead of x cubed, what's the first number going to be? X to the what power? Squared. So this one, 1x squared plus 0 x to the what power if you go down with your degrees of exponents. We have x squared. What's the next one down? X to the what power? First power. Again, everything I just wrote right there in purple is unnecessary, but I'm writing it as a placeholder for a second. Then the next coefficient, negative 2. We had x squared, we had x to the first power. This is x to the 0 power, so you don't need to write an exponent at all. And then plus 6. But notice we have at the end right here, we have negative 2, we have plus 6. We don't want to combine those. This is called a remainder. Plus 6 goes over the original denominator, x minus 1. And again, I know this, y'all, some of y'all looking at this and thinking, wow, this looks exceptionally difficult. It's not. It's just very, very new. And after you do a few of these, you're going to think this is probably one of the easier things we've done all year. So 0x to the first power, none of this is necessary to even having a problem. 1 as a coefficient isn't necessary. So this is what your answer is going to look like on this one when you simplify it. Not rolled like that. This. X squared minus 2 plus 6 over x minus 1. Do the same thing. Do the same polynomial, but divided by that one, x plus 2. Set it up the same way and see if you can come up with the proper coefficients and put them back where they belong. Okay, let's take a look at this. Now we're running a little quick, but we got to make sure we make time. Remember, the opposite of what this is what you divide by. So you divide in by negative 2. The coefficients are going to be the same as they were for the first problem. 1, negative 1, negative 2, and 8. Remember, make sure that a degree isn't skipped. If there's a degree skipped, you got to put a 0. When those show up, I'll show you what it looks like. This one goes straight down. 1. Multiply it by the negative 2. 1 times negative 2 is negative 2. Combine those two. So when you combine these two right here, negative 1 combined with negative 2 is negative 3. And then you go back again. You continue to go back to what's outside the box. Negative times negative is going to give you a positive 6 here. When you combine those two, negative 2 and positive 6, you get positive 4. And then one more time, go outside the box, 4 times negative 2. You get negative 8 here. Notice we have 8 and negative 8. When you put those two together, you get 0 there. So now, again, we got coefficients. 1, negative 3, 4, and 0. Go to the smaller degree, 1 degree smaller than what you start with, or what's in the numerator. That says x cubed. Remember, you're going to go x squared. So right here, this first one says 1, its coefficient, x squared. The next one says -3. You go down 1 degree. X squared, the next degree is x to the first. Then you go down 1 more degree, no x, or no variable. It's +4, and it's no variable. And then you have +0 would be the next one. That means there's no remainder there. So this one's neater since it doesn't have a remainder. It's simply x squared minus 3x plus 4.